How are you, students? This is the second discussion on chapter 5 of grade 11 physics. As we have discussed in the first video, we have seen that all the work concept and what does it mean. Work is the transfer of energy from one body to body, or transfer of energy from one form to the other form. So now the continuation of that discussion, we will see another example 2, worked example 2. Do you remember that the first example, the car gains energy because the acceleration, the force and the displacement are in the same direction, so that the work done was positive. That indicates the car gains energy from the engine, we have said. Now look, calculate the work on the car while braking. This is braking. The first case was what? Giving a fuel. That means giving energy or force from the engine to the car. Now braking to stop the car. Look the example. The same car now slows down. When a force of 300 Newton is applied opposite to the direction of the motion, while it travels 20 meters forward. When it is going forward, the brake is applied, brake pedal is applied to stop the car. So at 25 meters the car stops. Calculate the work done on the car. That means the energy lost by the car in the other way. Where will go the energy? To the environment, in the form of heat or in form of friction between the tire and the road. So the concept is this. The calculation is as follows. Look, the first step is what? Extracting the given, as mentioned in your note. The first thing is extracting the given. We have 3 givens, which are the force, which is 300 Newton, the distance in the opposite direction. Why the distance is opposite direction? Because the force is applied to or against. In this case, the force is applied against the motion. The force is applied against the motion. That means the angle between the force and the angle between the distance or the displacement is 180 degrees because they are in opposite direction. It is the force is applied against, as we have discussed before. So no need of unit conversion as the same problem we have discussed. So simply calculate the work done using the formula, which is force distance cos theta. W is equal to force times D times cos theta, magnitude. So simply substituting, this is simple to substitute 300 times 25 cosine of 180 degree. You know that cosine of 180 degree is this one. Here the cos value is -1. The cos value is -1. We have said that the angle will be measured from the positive x-axis counterclockwise, which is our theta. It's a positive because the motion was forward, okay, forward to the right, for example, but the force applied is backward. It is the force tries to make the motion of the car backward, that is stopping the car from its motion. So the energy is lost from the car. That is why the work done is negative here. Okay, so this value has a physical meaning, practical meaning. It tells you that the car loses energy. So where the energy goes, it is lost as a form of heat. It is lost as in the form of heat. It goes to the environment, and that is why you are looking at heat when the exhaust valve, when you, for example, observe the exhaust valve, there is a heat, there is energy loss. So the energy is lost from the car, not to the engine, to the environment, in the form of heat, in the form of other mechanical works, many more. So whatever the case, the car is losing energy because the force is applied against its motion. students, here mentioned refer your student textbook to see example for 5.2, which is on page 100. After that, okay, in that example, the force and the displacement is given in the component form. So please try to go through the example. After that example, answer the questions in the review part. Answer the questions in the review part of your textbook, which is page 101. You have two questions, a water container question and a man dragging a box question. So try these questions and please send me your answer. Okay? After that, we'll discuss the other things. After this, we'll continue another portion, but for today I will ask you another question from the entrance exam of 2010. Okay, which is number 31. Look here. Which one of the following forces can do work? Okay, based on your concept of work, answer this question. Okay, so your question will be, your homework will be 3 questions. 2 questions from your book and 1 this question. Which one of the following force can do work? A, kinetic friction. B, static friction. C, the gravitational force on a satellite orbiting the Earth in circular path. D, the tension force in the steering of an oscillating simple pendulum. These all are forces. So which of these forces can do work? Okay, which one of the following forces can do work? So please send me your answer. I'm eager to see your response. Thank you very much for your follow-up. So keep in touch. Good luck.